So in this video we're talking about a special type of sequence and then the related series called arithmetic sequences. Arithmetic sequences are just sequences that behave a certain way. The most important thing about arithmetic sequences is that they have a common difference. So a sequence is arithmetic is an arithmetic sequence if there is a number d called the common difference such that if you're starting at 1 in the first position, then our sequence is going to look like this. It's very important. So it's all based on where you start on. If you start at 1, your first position, then your sequence looks like this. If you start in the 0 position, then your sequence looks like this. So just be aware, there's two different ways this can be written. And it's all based on where did you start in the sequence, with the 0 term or with the first term. Okay, so that's kind of a subtle difference. So we want to state the initial term, the common difference, and write the formula for the following arithmetic sequence. Now it doesn't tell us if we're starting in the first term or the 0 term, so we're going to do it both ways. We're going to pretend that this is the first term. Well, since we're going to pretend that's the first term, then we're going to use this rule. So a sub n equals our first term, the first value in our sequence, plus n minus 1 times d. Well, the first value in our sequence is 3. Now what we need to find is our common difference, and then we have our sequence. We can represent this sequence using a closed form definition. So our difference, we just say 6 minus 3, 9 minus 6, 12 minus 9, and our difference each time is 3. So our common difference is 3. So now we're going to just plug in, and we get our sequence can be written as 3 plus n minus 1 times 3. So again, this is just a closed form definition for the sequence. For whatever n value is, n is our term position. So first term, second term, third term, fourth term, etc. Whatever n is, we're going to know the number in the sequence, not the series. We're not adding these up yet. Okay? Now let's go back and do it again and pretend that this is the 0th term. So if we pretend that's the 0 term, then we use this definition. So a sub n equals our 0, the value of the 0 term, plus n d. Well, we know the value of the 0 term is 3, so a sub 0. And our common difference is still 3. So we just plug it in, so a sub n could then be written as 3 plus n times 3. Let's call it just 3n. So what's going to happen is that these values, if I plug in, so for instance, if I plugged in a 1 here, 1 minus 1 is 0, so I generate the first term of the sequence. If I plugged in a 0 here, because I started in the 0 term, 3 times 0 is 0, plus 3 is the value of the 0 term. So again, this is why it's very important to pay attention. What term did you start with? Did you start with the first term, which we did in red, or did you start with the 0 term, which we did in green? Okay, and sometimes they're not going to tell you, so I would advise you to do both. It's not too hard, just make sure you know both formulas. Alright, so sometimes once we have an arithmetic sequence, there's what's called a series associated with that sequence, which we've already learned about series. It's just simply when we add up all the values in our sequence, then that sum is called the series. So here we have the arithmetic series. And it's pretty much, we're adding up all the values in our arithmetic sequence. Typically we're going to start in the 0 position, and it's going to be an indefinite sum, so we don't know where we're stopping. But just remember, you could start in the first term or the 0 term, so that's going to change how your sequence looks. All right, so in this example, what we want to do is consider the arithmetic sequence f. The initial term is f of 0 equals 3. So what this means right here is that in the 0 position, the value is 3. Well, a couple things just from that. 0 position means our rule is going to be a sub n, or sorry, let's call it f of n because that's what we're told. This arithmetic sequence is called f. So f of n is equal to f of 0 plus n d. That was our rule that we just learned on the previous value. We used a's in the previous page of this video. We're just changing it to f because that's what the problem gave us. No big deal, don't freak out. So here in the 0 position, so f of 0 is 3. That's what that tells us. Our initial value is 3. The common difference is 5. So d equals 5. All right, so now we know f of n equals 3 plus 5n. What we want to find is f of k, the sum of f of k. So f of n, capital, means we're looking for this series. And anytime you're looking for this series, that just means you're going to have sigma notation, because remember, a series is simply adding up all the values in your sequence. Okay, so we're going to start with, pretty much do what it says, sigma notation, starting in the 0 position, which kind of makes sense because we started in the 0 position to make our sequence, going to n. F of k, we're just going to replace this. Everywhere I see an n, I'm just going to put a k. So f of k, I'm just changing my variable, no big deal, because in my sigma notation, I started with k on the bottom, and I'm going to go up to n. So 3 plus 5k. Essentially, your variable on the bottom of the sigma must match your variable here in this problem. So, and actually, I left off the sigma here. That's my fault. So this is equal to sigma from k to 0, or sorry, 0 position to n of 3 plus 5k. And like I said, your variable on the bottom of the sigma must match the variable you're using in your sequence. Okay? No big deal. So essentially what we're finding is we're adding up all the values of our sequence. This is an arithmetic sequence. And now, like we did in the previous videos, we're going to apply our sum identities to create a closed form definition for this series. So I have the sigma of 2 sequences, so I can split this up into 2 separate sigmas. And again, the first sequence goes with the first sigma, the second sequence goes with the second sigma. Okay? Now, I don't have a rule to add up a bunch of 3's, so I can rewrite that as 3 times 1. And then my coefficient of 3 gets to come out. That's an ugly sigma, so let's rewrite that. Now, 1 just falls down. I'm done with the coefficient for now, so it's going to fall down. Now I need to rewrite this sum right here. I do have a rule for adding up a bunch of 1's, and it's all based on your starting position. So when you're starting in the 0 position to add up a bunch of 1's, that's just going to be n plus 1. The variable you use when you make your closed form definition is going to match the top. When you start off, it matches the bottom. When you finish with your closed form definition, the variable you use is going to match the top every time. Plus 5 is coefficient. It gets to come outside of your sigma. N on top. And then k is left on the inside. Well, we're adding up a bunch of unknown numbers. That's our think Gauss identity. So we have 5 just comes down. Think Gauss was just, again, we're using the variable on top. So n plus 1 divided by 2. And so now we have our closed form definition for the arithmetic series. Again, a series is just adding up all the values in our arithmetic sequence. I want to clean this up though as much as I can. So I have 3n plus 3, just using distributive property. Distributive property on the inside here. I have n squared plus n divided by 2. Now I want to take care of this distributive property, so 3n plus 3 just falls down, plus, there should not be an equals there, plus 5n squared plus 5n divided by 2. And finally, I want to clean this up as much as I can. So 3n plus 3, I want to think of that as over 1 and add these two fractions together. Before I can do that, though, I have to create a common denominator by doing my 3 crosses. Again, I did this in our video in chapter 1, so you might want to go back and check that out. So along the bottom, I have 2. Going from the bottom to the upper left, I have 6n plus 6. Going to the upper right, I have 5n squared plus 5n. And plus goes in the middle. Now I want to combine like terms wherever I can. So I have 5n squared plus 11n plus 6 divided by 2. This is the closed form for the arithmetic series. Okay? And that's it for this video. So again, we created the first example, we created an arithmetic sequence, which is just an order list of numbers. We did it twice based on the first position, and then again based on the 0 position. Then in this example, we were told to start in the 0 position. We created the arithmetic sequence, and then we found a closed form definition for the arithmetic series that was associated with that sequence. That's it.